Hello everyone, this is the fourth video of the time complexity series, and before starting this topic, I want to clear one point here that if you haven't seen the previous videos, please refer the previous video first, otherwise you will not be able to understand this video clearly. Yeah, that is the disclaimer I want to give before starting this topic. Okay, so till now what I have covered, we have covered what is the time complexity and how it is different from the real time of execution, why we cannot identify the performance of any algorithm with the help of time of execution. And after that I discussed order of growth and how we use asymptotic notation for different cases. Now how to calculate time complexity of any algorithm. So suppose you have given a program, okay? So you have to think about different cases for that program. You have to think the worst case of that program and best case of that program. After that, for worst case or best case, you have to create a function that represents number of operations. After creating that function, you have to calculate order of growth of that function for every case. First you will you will identify the worst case, and then you will identify best case, and you have to calculate order of growth for these two functions, best case and worst case. Okay, suppose in case of order of growth, suppose the order of growth is same, is different. For worst case the order of growth is different, then you use big O notation for that. And for the best case, if the order of growth is different, for the worst case, then you use big omega notation. And if the order of growth is same in worst case and best case, then you use big theta notation for that. So here, as you can see, the simple example one here. So here it is the function of linear search, where it is taking the key input, and it will go through all the element of array, and it will search whether the key element is present in this or not. So what could be the best case for this? So suppose when computer execute this program, and just at the first position of array it finds the key element, then it has to perform this operation just one time. And what will be the worst case? Worst case will be like this, that you are getting the element at the last position of the array. So you have to iterate this array you have to execute this line of code n times. So in the worst case, the PC will execute for this line of code, it will be n times. So yeah, for worst case we have to create a function, and for best case we have to create a function. So we create function like this. This line of code will be executed by PC one time, so this comes just one. So this line of code execute by PC for best case one time only. This line of code also one time, to just one time. So this line of code also one time. For the best case, the function that represents number of operation, it will be 4 only. But for the worst case it comes this much. Now I have to calculate the order of growth. So order of growth for this one is 1, order of growth for this one is n. Now if you think that how I have to calculate order of growth, then you can see my previous video. There you will find easily how we can calculate order of growth. Okay, now because it is the best case here, so you use here big omega notation for this order of growth. So you have to just simply symbol here big omega, and you have to keep one inside, the order of growth inside. In the same way, for the worst case scenario, you have to do the same. You have to use the asymptotic notation big O, and in the bracket you have to keep the order of growth here. So this is the time complexity for this program, for the worst case scenario. for this program, the time complexity for the worst case is this much, and what it is, big O n. Now I think that you are very clear. In the same way, for this program, in the best case, the time complexity will be big omega 1. It means constant time. Okay. Now I am giving another example where we use big theta notation. Okay. Suppose here it is simple iteration where you are giving input to this function n. Now the loop will execute this line of code n times. So yeah, so suppose in best case also the function what we will create, it will take this number of operation, and for the worst case also it will take the same number of operation. So order of growth for the best case, for the worst case it will be same, because the order of growth for the best case and for order of growth for the worst case is same. So we use big theta notation here. It represents that in any case, whatever case you take, it has to take just this number of operation only. That is why it is called exact growth rate, not more than that, not less than that, in every case. Okay. So now I think that time complexity things is very much clear to you. And if you really like this video and like this whole series, so you recommend your friends